Today we're going to talk about rate of change. So we've talked about unit rate. Rate of change is just another word for it. So we're going to talk about how to find it and then how that relates to slope. So first, to find rate of change, first thing we do is you write the changes of y and the changes of x. This means we take 2 points, find their y coordinates and their x coordinates, and we subtract them. When it says changes, that's just a fancy way of saying we subtract it. Then we fill in the ratios of the change in y. So we subtract our 2 y's, and then we subtract our 2 x's. Now we're going to talk about this in a minute, but we always put the second point first and the first point second. All right, that's kind of confusing, terrible choice of words there, but we'll talk about that here in a minute. So next, if there are equal, so if your ratios are equal, we call that relationship constant. So let's look at an example of that. So this is an example of a constant ratio, okay? Constant rate of change. So you'll notice this is talking about Anna keeps a record of nights she babysits and the money she earns for 2 months. So after 1 night, she earned $12. After 2 nights, she earned $24. After 6 nights, $72. And after 10 nights, $120. So we're going to do the change in y. So that means we take our change in y is down here. So we do our second number, so 24 minus 12, which is 12. Then we do 72 minus 24, we get 48. 120 minus 72, we get 48. I do the same thing for the x's. 2 minus 1 is 1. 6 minus 2 is 4. 10 minus 6 is 4. So my change in y's, so I'm going to pick the first one out here, was 48. And its x, or change in x that goes with those points, is 4. Same thing for the next one, 48 over 4, and then 12 over 1. So you'll notice all these ratios are equal to each other. 48 over 4 simplifies to 12 over 1. So they're all equal to 12. This is an example of a constant rate of change. It's always the same. So now, let's talk about what happens if they are not equal. So if your rate of change is not equal, we call that relationship variable. All right? It means it's changed. So variation means changing. So let's take a look at those. So this is a variable rate of change. So let's talk about it. All right, so let's say right here, this is 20 minus 12. Well, that's 8. 2 minus 1 is 1. So 8 over 1 is 8. But you'll notice 70 minus 20 is 50. That divided by 4 is not equal to 8. And you'll notice the next 2 points, if we were to subtract their y and x, we get the same thing, 50 over 4. That is not the same thing as 8 over 1. So these ratios are not equal. So when we have when we have relationships that are not equal, this relationship is called variable. So now we're going to bring in that 8th grade topic I've been telling you about called slope. All right, so this is just another name for unit rate. It describes how steep a straight line is. Okay, so we're going to be able to tell how steep a line is on a graph. When the rate of change is constant, we call it slope. All right, so remember the 2 relationships we just talked about. We had constant and variable. So when it's constant, we call it slope. Now, to find the slope when 2 points. So I only need 2 points to find the slope. I need a 0.1 and a 0.2. If I have that, I can make a straight line and I can find slope. So we find the 2 points and then we write them vertically. Then, or you can write them horizontally, whichever way you want to write it. Okay, it says vertically in your notes, but I'm going to show you horizontally, and I'll see if you want to do it that way as well. So first thing we do is we subtract our y's. We find the change in y. Remember I said this just a minute ago. This was talking about subtracting y's. So then to change in x, same idea, is subtract. Okay, so we're going to subtract our x's and our y's to get the change. Then we will divide or simplify our change in y, so y goes on top, and a change in x. Remember when we talked about unit rate, we did y divided by x to find that constant of proportionality. We do the same thing here. We subtract our y's to find the change of y, and we divide that by the change in x. So slope is the same idea, y over x. So on your notes, there's 4 graphs over there, and we're going to talk about the different types of slope you may encounter. So right here, we have our change in y. So of course, the y-coordinate is the second coordinate, all right? So that's this one right here, so 5 minus -5, okay? So what happens with 2 negatives here? So it looks kind of funny. I'm going to put parentheses around that just so it doesn't look as funny. But remember, minus a negative is the same thing as 5 plus a +5, which is, of course, 10. So our change in y here is 10. So our y's go down 10. You could have took from this point, you could have counted down 10 spaces, and you would have been on the same level as this next point. Or you could have counted up 10 spaces and been on the same level as this one. So go from here, this is our point 1 to our point 2, up 10 spaces or 10 squares, and we would have been level with this one. So now let's find how far right we go from this one. Now our second point is 6. All right. So notice this is what I was talking about earlier when I was going to talk about. Right here I use 5. So because I use this 5, I have to use this 6 as the first thing here. So 6 minus -4. Okay. Or that's the same thing as earlier as we said 6 plus +4. Remember, minus a negative becomes plus a positive. That is, of course, 10. So our change in x is also 10. So now we take our change in y, which was this. So I'm going to change that color so we can distinguish the two. Our change in x was the second 10. Well, 10 divided by 10 is, of course, just 1. So our slope here is 1. Now, it says the word positive here. So this is a positive slope. So when I go from left to right, when my line goes from left to right, like this right here, is a positive slope. So that's why we got a slope of +1 here. So this also means that each time we go over 1, we go up 1. Up 1 over 1. Up 1 over 1. You'll see that right here. It continues going like this all the way until infinity. It never stops. So we keep going up 1 over 1. Up 1 over 1. So that is a positive slope. So now we're going to look at negative slope. So you'll notice the first thing you notice about this line is it going the opposite way. Remember, our positive slope went this way. Our negative slope is going to go this way. So let's talk about the change in x or y here. So I don't care which point you pick first as your number 1 point. I'm going to pick this bottom one down here. So I'm going to say 0 is our 7 is our first y, okay, or second y, minus our first y, which is 0. And I did that just because I don't want to deal with a negative number if I don't have to. So, of course, 7 minus 0 is 7. So our change in y here is 7. So now let's talk about our change in x. So because I picked this as the first point written, I'm going to have to put -2 first, minus 1. Okay, because I picked 7 first up here, I got to do its x that's coordinated with it or associated with it. Now, of course, that's equal to the same thing as saying -2 plus -1, which equals -3. Okay, so our change in x is a negative number, which makes sense because we don't want both these to be negative. If we both got negatives here, it'd make our slope positive, and that's not what we're looking for. We said it's a negative slope. So, of course, this does not simplify, so I can leave it as 7 divided by -3. Or it does simplify. If we want to write it as improper fraction or a mixed number, it'd be, so 3 goes into 7 2 times. So we'd have -2 and 1/3. Okay, so our slope here is -2 and 1/3. It's a negative slope. This means for every -2 and 1/3 I go up, I go over 1. -2 and 1/3 I go up, I go over 1. So this is what this means right here. It's a negative slope, okay? So now let's talk about if our line is straight like this. We call that a 0 slope. So we do the same thing. We do a change in y. So it doesn't matter. They're the same number. So -5 minus -5 is the same thing as -5 plus 5. And of course, these two cancel each other out, and so we get 0. So our change in y is 0. Now let's do a change in x. So it doesn't matter. I'm going to do 7 minus -6. This becomes 7 plus 6, which is, of course, 13. So our change in x is 13. But if I divide anything into 0, my answer is always 0. So the slope here is 0. There is no going up over 1, going up over 1, going up over 1. So as long as I find my change in y and change in x and I get 0, there's no change in our y. You'll notice that here. So I didn't go up any or down any. I stayed the same level. Anytime you see this on a graph, know that your slope's going to be 0. Your rate of change or your unit rate is going to be 0. So now let's talk about what happens if we got a straight up and down line. So there's no change in our x here, but let's go through it. So change in y. So let's say this is our second y. So I'm going to do 8 minus 1. 8 minus 1 is, of course, 7. But let's do our x's. 7 minus 7 equals 0. So the x associated with 8 is 7. The x associated with 1 is 7. So I have 7 divided by 0. Well, if you tried this on a calculator, it would spit this ugly message with it. This is not, we can't do this. We call this undefined. So I'm going to put UND. So we call this undefined. There is no slope. We can't say there's any steepness to this. So this is when you have an undefined slope. So let's go through the 4 slopes again. So we have positive slope. So this is when we're going from left to right, and we're going up and over right. So we go up, over, right. A negative slope is when we go to the left or we go down, okay? So it goes the opposite way as the positive slope. You'll notice the difference. This one goes this way. This one goes this way. So our slope should be a negative number. If it's not, we've done something wrong. If it's a flat line like this, we call this horizontally. So it's if a horizontal straight line, we have a slope of 0. There is no change in our y's here. And then if we have a straight up and down vertical line like this, no matter where it is, as long as it's straight up and down with no steepness, no defined steepness, we call this undefined. There is no change in our x's. So now that you've done this, I want you to try your work on slope and see how far you get.